Yeah, so if you could change the thing that you're writing with, so your connections, directions, whatever, your comments are different looking. This is also a with calculator, so you didn't have to show a lot of work. So guys, part A, all you had to do was the derivative of V and evaluate it at A.
Oh, we just need to find
So, typing that in on the calculator, how do I do that?
Wait, is this being graded? The second, or you go to math.
Okay, hold on, guys. So we go to math.
Then
Number
You
8.
actually did it by
Yes.
And then you put in the function 1 minus inverse tangent e to its x.
Okay, guys, really. So if you're wondering how to do this on the calculator, it's what I'm showing you right now. The 84 is much more straightforward and like kind of looks like do the derivative and should be self-explanatory of how to type it in. On an 84, Sam is telling us math 8 gives us the derivative thing, then you type in the equation, make sure it's tan inverse, not tangent to the -1, I don't want the reciprocal, and it's of e to the x. So let's see, I closed the parentheses around the x, and I'm not sure I needed that parentheses there. Then what do I do?
And then I don't know how to do it on the 83, but it's equal to, that point equal to 2.
So, comma with respect to x evaluated at 2.
Yeah.
And I better be e to the x. Am I forgetting parentheses? So, all right. So, sorry, what? Okay. Well, and you need to label stuff. Don't leave floating arithmetic. Say, this is acceleration at 2. And some years, sorry, I don't know always when, because I don't know when they're picky. Some years they needed you to say, that is V prime. Like, how does V relate to A? Velocity, the derivative of velocity is acceleration. So it's 1 point just for the answer. Okay? Those of you grading the papers, how many got that one right? Okay. All right. So the next one, is the particle speeding up or slowing down? The thing you need to check is, well, acceleration at 2 was negative. We need to see if the velocity, what sign the velocity had at 2. If they match, if velocity and acceleration are both negative, it's speeding up.
What?
If they are mismatched,
What do you mean?
okay.
I thought.
Swear to God, we did that.
Okay. I thought the derivative of a function, if the derivative is negative, then the function is decreasing.
Okay. If this, hold on. If this is my velocity, guys, to explain, if this is my velocity, is the velocity increasing right here? It went from 0 to 1 to 2 to 3. Then right here, my L, I went from 3 to 2 to 1. Right here, I'm stopped. And then I am going backwards, but I have speed. I'm going backwards with 1, -1, -2, -3, -4, -5. Am I speeding up here? Oh, yes, I am. Don't give me that look, sir. So here, velocity was positive, and acceleration, which is the slope of velocity, positive, positive, speeding up. Here, velocity was positive, but acceleration, the derivative, the slope of, was negative. Plus minus, that's slowing down. Here, velocity was negative, but so was the slope of velocity, known as acceleration. I am speeding up. So if the signs match, your speed is increasing. Okay? All right, part C. When does the particle reach its highest point? I was confused by this when I read it. I was like, what the heck are you talking about, highest point? I don't have position, but it tells me this velocity is along the y-axis, so it's going up and down. Okay? So when I got to this question, I was like, what the heck are you talking about? And then I reread the question because I didn't actually read it in the first place. So I skipped step 1 and 2. Step 1 is,
Read the question.
and step 2 is, no, really, read the freaking question.
Reread the question.
Yeah. Which for me was read it for the first time. So where does the y value hit its maximum? Look at its derivative, which they gave me. It's known as velocity. Where does the velocity equal 0? So here you get a point just for saying I am checking where velocity is 0. If you solved it incorrectly, you still get the point for going, okay, I'm gonna find when that is 0. And then enters the calculator and all hell breaks loose. Y'all don't know how to do it well. But typing it in, solving it however you guys are good with using your calculator to find where does that hit 0. It has exactly one critical point. And it's really, really, really close to 0. It's 0.443.
Do the intercept.
So, all right, if you want to see how I did it, I typed in 1 minus arctan of e to the x,
I got it.
and I set my window from x values.
Yeah, the window is like.
So I changed my window to be 0 and bigger because I don't want to go backwards in time. They told me time was positive. Big cross right there. Second calc. Do I want intersect? Do I want maximum? What do I want? The 0. Go to the left. So you guys, here's a shortcut that I've shown you before, but you might not remember. The little blinky, it's not in the right place. I'm going to move it all the way over to 0 quickly by hitting 0. So there it is. And then it looks like, well, if I hit 1, the little arrow things are, the crossing point is in between them, and it will tell me it is 0.443. So that is my one critical point. And then you need to justify that it's a minimum. So the way I show this, so since the velocity, like the number line is not enough, it's great to use it, and then you need to put words to it. Since the velocity went positive to negative at that specific x value, velocity was the derivative of position. The y position will be a maximum at that point. Noah?
So like, even if you got it right, it didn't like, specifically say v of t equals 0, you don't get that point.
If you did not say v of t equals 0 somewhere on that paper, you do not get that point.
The whole, like all three of them?
This one,
Oh.
however, like,
I don't know how you would like do that
like,
in terms of the process of the problem. I don't know why you'd skip these.
so the grading of these is getting there. It's changing a little bit over time because the last year's rubrics, they were like, well, if they didn't show this step, but then they showed like here, as Sam was just saying, you couldn't have gotten to here if you didn't do that one first. Sometimes they're like, well, if they showed this, they get that 1 point, but if they messed it up by here, they still get that 1. But if you get this one correct, but you had to get it correct, then they would have given you both. So I don't know the answers to all these. But this piece was 3 points. One for knowing that you were setting velocity to 0, finding the solution to that, and then making the argument that it's a maximum here because number line's not enough. Okay, the last thing. Did anyone pick the paper they're grading get all 3 of those right? All 3? Okay. Okay, the last piece says, find the position of the particle at time 2. Is the particle moving toward the origin or away? Well, Where is the particle at 2? You gotta reread the question for that little known piece of information that we didn't use yet. It says at time 0, sorry Natalie, step 1 and 2 was read the question. So where did you start at time 0? I started behind the origin. And then 0 to 0.443, I went forward, but then for the rest of the time I was going backwards. This is accumulated displacement. Like, where did I end up from where I started? Added on to the beginning, I ended up behind where I started. And I'm still going that way. Am I moving towards the origin or away? Away, right? So, lots of points in here. If you have the integral from 0 to 2 of velocity, that's a point. If you took into account the initial condition, you knew that you needed that first spot. Yes, Josh? Can I zoom in a little bit? So, handles the initial condition. If you didn't read the question, but you wrote this as an AP grader, I would have given you the 0.4. You knew that you needed that value. If you didn't read it and find the value in the thing, I would still give that point because you knew you needed it. You then would not get this point because you need to actually get the number. You need to get the correct number of y of 2. And then answer with the reason. Like, okay, my y position is lower than it where I started, so I'm moving away from 0. Cool? Okay, can you give the papers back to people? And can you clear your desk? Now you get a actual exit card thing.
With calculator?